So let's solve this question now. This is JAM 1982 question. So they ask us to look for the weight acting downward and this angle. So these are what they are concurrent forces that are acting from a point. So they are all acting from the point. All of them have the same point, that is similar vertex. So they are all acting from here. This one is going out, this one is going out, this one is going out. Before I go into this or explain further, I have to discuss something called vector, the head and the tail. So this is what the tail of vector, this is the head of a vector. So when we are resolving this, we want to resolve this into a triangle. We have to make sure that the head of one is touching the tail of the other, where they make a vertex. So let's say this is the head, and I bring another one. Let me bring another one here. When I head the head, let me bring the tail of another one. So this is the tail of, let's say, vector 2, this is vector 1. So the head of vector 1, which is this, is touching the tail of vector 2, which is this one. So this is where it's touching. So this is what we are going to be doing in these concurrent forces. So we'll draw out this one, which was the weight, right? The weight always act downward. Let's draw out all what we have here, which is just simply this. Let me put it here. This is what we have. This one is this. So let me write W here. The whole length was W. Now, this is the head of W and this is the tail. So what I'm going to do is that we write out the second one. We are done with this one. So this is the second one. Let's bring out this one in such a way that the tail of this one will be touching the head of this one, like the same thing. So bring this one, I'll bring it here. This is what 3 kdf. So you can see that here now, this is the tail of this one is touching the head of this other one. See how it makes a lot of sense. Now we have the next one, which is this 5 Newton here. So if I bring it here, I'll put it here like just you bring it the way it is. You see the way this one is now is due east. You bring it like that. This one is what due south. You bring it like that, just like that. So you have to bring this one in this direction, which is what this one is in the northwest direction. I'll bring it like this. This makes a lot of sense. This is 5 df, right? This is a right angle. So there's an angle here, and that angle is this angle here. You can see they are the same thing now. So guess what? X. This makes a lot of sense. Now we want to look for W, which is the weight, and also look for what? The X, which is the direction of this resultant here. I call it a resultant. Actually, it's a resultant. Anyway, let's look for what W is. Which one should I look for first? Let's look for what W is first. So here's the longest side. We know that longest side, we're using a cosine rule. We know that r squared is equal to, let's use f1. F1, or let me use a squared plus b squared minus 2ab cos theta. So this one, but we know that we are using negative. We're looking at the angle that this resultant, that this longest side is facing. What angle is it facing? 90 degrees. So cos 90 is something at 0. So it will render everything here useless. Everything becomes 0. So everything here will be what? 0 when cos 90. 0 times anything is 0. R squared. So equals to what? A squared plus b squared. So 0 doesn't mean anything. So we have to look at this. This is what we are going to use now. Now, what is the resultant? R, the longest side is what? 5. So I'll make here to be what? 5 squared equals to A. Let's make any one. Let's call this one A. So we have 3 squared plus B. What are we going to call B? This side. Let's call B this side. So W squared. Right? So this makes a lot of sense now. So we cannot do what? Collecting of like terms. So 5 squared, take this one to this side, we now have what? Minus 3 squared equal to W squared. So 25 squared is The sorry 5 square is 25 minus 3 square is 9 equals to 5 square. Now when I resolve it, what am I going to get? I will get 16 equals to W square. So I'll square root both sides, I'll square root here, and I'll square root this one. So when I square root this one, I will have 4. When I square root this one, the square root of cancel square, I will have W. This makes a lot of sense, right? So W now is equal to 4. Now we have solved what W is, that is 4 Newton. Then what is the angle here? We know that this angle, opposite of this angle is this. This is the opposite, and this is the height, right? And down of it is what the adjacent. So we can use cos, sine, or whatever to find our answer. But um, let me use sine. So sine of x, which is the angle x, is equals to what's the opposite? Is 3. What's the height? Is 5. So x is equals to sine inverse of 3 over 5. So x is equal to, when you do the math here, we are going to get 36.89 degree, and that will be our answer for x. This is x and this is w. So that's how we solve simple question like this. So once you resolve all your form your triangle. Once you see that it's a right angle triangle, there's no need of writing this one again. Just move that r square is equals to a square plus b square, where the longest side here is what r square, then equals to a square plus b square. So that's how you solve questions. Let me see here. So we look at the Lamin's theorem later on. We look at that one in the next